Okay, in part 2 of our podcast on partial fraction decomposition, we're going to learn how to deal with repeating linear factors. These would be linear factors of the denominator that are of the form ax plus b, for example, x minus 3, x plus 2, something like that, but it would be repeated. For example, any linear factor that has a power on it. In that case, I need to have a decomposition term of this form for each power of that repeating linear factor. So if, for example, if that repeating linear factor has a power of 4 on it, I would need a single power, a power of 2, a power of 3, and a power of 4. Okay, so you'll see an example of that in just a minute here. Okay, I have this rational function. The first thing I need to do is factor the denominator. When I do that, I get a non-repeating linear factor and a repeating linear factor. Okay, the non-repeating linear factor we just learned how to do in part 1. The repeating linear factor we're going to do here as well. Here's my term, my partial fraction decomposition term for the non-repeating linear factor. Here's another term for the single power of the repeating linear factor, and here's another term for the power of 2 of the repeating linear factor. All three of these are necessary. Now what I'm looking for is what value should a, b, and c have in order to make this equation true. Just like I did the last time, here's my equation. I'm going to take this equation and multiply both sides by this denominator over here, and that's what I've done here. Okay. When I multiply on this side, this denominator will cancel with the multiply here, and I just get 5x squared plus 3x plus 1. There it is. On this side, when I distribute this multiply into the first term, the x minus 2 will cancel with the x minus 2, and I'm going to get a times x plus 1 quantity squared. There it is, a times x plus 1 quantity squared. When I distribute this multiply into the second term, the x plus 1 will cancel with one of the x plus 1's over here, and I'm going to get b times x minus 2 times the other term, or the other factor of x plus 1. So here it is, b times x minus 2, quantity x minus 2 times quantity x plus 1. And the last time that, or the last term that I distribute this to over here, the x plus 1 quantity squared will cancel with the entire x plus 1 quantity squared, and I'm just going to get c times quantity x minus 2, and there it is right there. Okay. Now I'm going to FOIL all of these things out and distribute in, and I get this expanded version right here. And again, the factor of x squared has to equal the factor of x, or the coefficient of x squared has to equal the coefficient of x squared. So I'm going to get 5 is equal to a plus b. The coefficient of x has to equal the coefficient of all of my x terms. So I'm going to double underline those. So I'm going to get 3 is equal to 2a minus b plus c. And my constant term has to equal all of my constant terms over here. So 1 has to equal a minus minus 2b minus 2c. 1 equals a minus 2b minus 2c. This gives me a system of 3 equations in 3 variables, and again I can solve that using any method at my disposal. The solution is that a equals 3, b equals 2, and c equals -1. And when I plug those back in, 3 for a, 2 for b, and -1 in for c, I get this partial fraction decomposition of my original rational function.